Betelgeuse, the star, is a red supergiant located in the Orion constellation. It has long captivated astronomers and skywatchers alike due to its enormous size and luminosity. If Betelgeuse were situated where the Sun is, it would extend all the way to Jupiter's orbit, showcasing its immense dimensions. Despite being approximately 642 light-years from Earth, its sheer size makes it one of the most brilliant stars visible to the naked eye. In recent times, however, Betelgeuse has shown some unusual activity, including unexpected dimming and brightening cycles, which many scientists believe may indicate that the star is nearing the end of its life. Recently, world-renowned physicist Brian Cox made a groundbreaking declaration. Betelgeuse is on the verge of a devastating explosion that is anticipated to take place within the next 2 weeks. This event, known as a supernova, will mark the final stage of Betelgeuse's existence but will present an extraordinary opportunity for scientists to examine one of the universe's most powerful and spectacular phenomena. As a huge star approaches its end, Betelgeuse, classified as a red supergiant, one of the largest and most massive types of stars in the universe, has been under observation for centuries. But its recent erratic changes in brightness have sparked speculation that it may soon go supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under the immense pressure of its own gravity, resulting in a massive explosion that releases an incredible amount of energy, material from the star, and radiation into space. Betelgeuse's imminent explosion is expected to be a Type II supernova, a specific kind of stellar detonation that occurs when the core of a massive star collapses. With this core collapse comes the release of neutrinos and radiation, which create a shockwave that disintegrates the star. The explosion will be so intense that it may even be visible from Earth without the need for telescopes, possibly even outshining the moon in the night sky for several weeks or months. While a similar occurrence would normally be destructive if it occurred closer to Earth, the distance between Betelgeuse and our planet, around 642 light-years, means that although the explosion will be dramatic and visible, it won't pose any risk to life on Earth. This event, however, promises to revolutionize our understanding of supernovae and cosmic phenomena. A supernova is one of the most energetic occurrences in the universe, releasing more energy in a short period of time than our Sun will over its entire lifespan. Betelgeuse's explosion will not only be a dazzling celestial display but also an important scientific milestone. Scientists who study such events are eager to monitor this rare incident from the very beginning, utilizing various ground-based and space-based telescopes like the Hubble Space Telescope and the James Webb Space Telescope, JWST, to collect as much data as possible. When Betelgeuse explodes, it will emit a wide spectrum of radiation, ranging from gamma rays to visible light. One of the most critical aspects of the supernova will be the flood of neutrinos, elusive subatomic particles that seldom interact with matter. Neutrinos from a supernova can actually arrive on Earth before the light from the explosion itself due to their ability to pass through nearly everything without being affected. Observatories like Japan's Superkamiokande and Antarctica's IceCube Neutrino Observatory are preparing to detect these neutrinos, which will give scientists an early start in observing the final moments of Betelgeuse. Additionally, the explosion will offer crucial insights into the formation of heavy elements. When stars go supernova, they forge and release elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse supernova will allow researchers to observe this element creation process in real time, which is vital for understanding how planets and the universe's chemistry come together. Although Betelgeuse supernova is not expected to have harmful consequences for Earth, it will likely interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the arrival of cosmic rays and charged particles, may produce more powerful auroras, expanding the regions where the northern and southern lights are visible. While these cosmic rays could potentially interfere with satellite communications and some technologies on Earth, any disruptions are expected to be minor and brief. One of the most exciting features of Betelgeuse's explosion is that everyone will be able to see it, not just professional astronomers with high-tech equipment. For weeks or even months, Betelgeuse is anticipated to be the brightest object in the night sky, possibly even visible during the daytime. This spectacle will not only captivate the scientific community but also engage stargazers and the general public, sparking renewed interest in astronomy and the cosmos. Astronomers have long speculated about the death of Betelgeuse, but Brian Cox's recent statement adds a sense of urgency to the situation. Over the next few weeks, observatories around the world are preparing to study every stage of the supernova, and the data collected will be priceless, potentially transforming our understanding of stellar evolution, core collapse supernovae, and the distribution of cosmic matter. The supernova of Betelgeuse will also provide a rare opportunity to refine our models of cosmic distances. Being relatively close to Earth, it provides a chance to observe how energy from such an explosion travels through space. By studying the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust that exists between stars, astronomers will gain a better understanding of the size of the universe. This event will also provide a golden opportunity to investigate dark matter and how it may influence supernovae. Dark matter, the mysterious substance that represents approximately 85% of the universe's mass, doesn't emit or absorb light, making it difficult to detect. But observing how light and matter behave around Betelgeuse after its explosion could provide indirect clues about the role dark matter plays in shaping the universe. Betelgeuse supernova will also bring us closer to comprehending the life cycle of stars, especially how massive stars contribute to the creation of the elements necessary for life. Supernovae are the primary cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even life itself. By learning from Betelgeuse, scientists will obtain crucial data on how these elements are forged and distributed. Dark energy being one of the most elusive. While Betelgeuse supernova won't directly expose dark energy, the explosion's impact on surrounding space, including how light and matter interact in the aftermath, could provide indirect evidence about how the universe expands and evolves. Observing these interactions could refine existing cosmological models and potentially help distinguish between competing theories about the fate of the cosmos. Another speculative but exciting possibility is the formation of either a neutron star or a black hole from the remnants of Betelgeuse core. If the remaining mass is below a certain threshold, it will become a neutron star, an ultra-dense sphere of degenerate matter. But if the core's mass is great enough, it could collapse further into a black hole, an object so dense that not even light can escape its gravitational pull. In either case, the formation will provide vital clues into the physics of matter under extreme conditions. Moreover, the explosion might create gravitational waves, ripples in spacetime predicted by Einstein's theory of general relativity. Instruments like LIGO and Virgo are now sensitive enough to potentially detect these waves, offering an additional window into the structure of the event. If confirmed, it would be one of the first times scientists could correlate visible light, neutrinos, and gravitational waves from the same stellar explosion, marking a new era in multi-messenger astronomy. Public engagement in the coming weeks will likely reach unprecedented levels. Social media, news outlets, and scientific institutions will provide real-time updates, educational resources, and live streams of the event. Schools and universities will incorporate the supernova into their curricula, turning a once-in-a-lifetime event into a powerful learning opportunity for students around the world. The supernova of Betelgeuse won't just be a scientific milestone, it will be a shared global experience, uniting people under the same sky. As we witness the brilliant death of this ancient star, we will also be reminded of our small but meaningful place in the universe. Matter and dark energy. These elusive forces are believed to account for the vast majority of the universe's mass and energy, yet they remain poorly understood. Some scientists speculate that supernovae, like the one anticipated from Betelgeuse, may hold the key to unlocking some of these mysteries. Supernovae release an extraordinary amount of energy and radiation, and some researchers believe these mighty forces might interact with dark matter in ways we can observe and study. One fascinating hypothesis is that dark matter exists in the form of weakly interacting massive particles, WIMPs. If they exist at all, interaction with the energy generated by Betelgeuse's supernova could provide critical clues to their nature. Such a discovery would be groundbreaking, offering the first direct evidence of dark matter, an elusive phenomenon that has confounded scientists for decades. Similarly, Betelgeuse's explosion could offer insights into the nature of dark energy, the mysterious force driving the accelerated expansion of the universe. By studying the behavior of energy and light during the supernova, scientists may gather crucial information about how cosmic events like these influence the universe's expansion and how they might be connected to dark energy. The upcoming explosion of Betelgeuse offers a unique perspective on the life cycle of massive stars, which play a crucial role in the cosmic ecosystem. Red supergiants like Betelgeuse are rare, making their study necessary for comprehending stellar evolution. These stars form from clouds of gas and dust that collapse under gravity, eventually igniting nuclear fusion in their cores. As they exhaust hydrogen, their primary fuel, they expand dramatically, shedding their outer layers. This mass is carried away by powerful solar winds. The loss contributes to the enrichment of the interstellar medium, paving the way for the formation of new stars. When Betelgeuse goes supernova, it will not only offer insights into its own life cycle but also serve as a cosmic laboratory for studying the conditions under which stars live and die. Researchers will closely monitor the aftermath of the explosion to determine whether a neutron star or black hole forms at its core. The nature of this remnant will provide valuable details regarding the physical processes that govern the final stages of stellar evolution. The dynamics of the explosion itself will also provide a wealth of information. The shock wave produced by the supernova will sweep through the surrounding gas and dust, heating it and causing it to glow brightly. This emitted light will offer astronomers clues about the elements synthesized during the explosion, such as iron, nickel, and other heavy elements. By analyzing the spectral signatures of these elements, scientists will be able to determine their abundance and distribution, deepening our understanding of how these elements propagate through space and contribute to the formation of future stars and planetary systems. Another area of interest is the potential for gravitational wave detection. As the core collapses and the supernova unfolds, it may generate ripples in spacetime that can be detected by observatories like LIGO and Virgo. The gravitational waves from these events carry information regarding the underlying dynamics of the explosion, potentially offering new insights into the physics of supernovae and black hole formation. Betelgeuse's explosion could also act as a catalyst for technological advancements in astronomy. The anticipated surge of observational data will likely push the boundaries of current astronomical instruments, possibly leading to advancements in imaging technology, data processing, and real-time analysis. These innovations could benefit a wide range of astrophysical studies beyond just the supernova. Public engagement will play a crucial role in Betelgeuse's supernova, fostering a sense of wonder and curiosity about the universe. Educational programs, outreach initiatives, and citizen science projects can use this event to inspire the next generation of scientists. Schools, universities, and research institutions may organize viewing parties, lectures, and discussions that emphasize the importance of comprehending the universe and our place within it. As we prepare for this monumental event, excitement is building throughout the scientific community and among amateur enthusiasts. The anticipation surrounding Betelgeuse's supernova encapsulates humanity's desire to explore the unknown, challenge our understanding of the universe, and unite us in our pursuit of knowledge. The death of a star becomes a powerful reminder of the cycle of creation and destruction that defines the cosmos, urging us to think about our very existence and the mysteries that lie beyond. As the world awaits the supernova of Betelgeuse, astronomers are coordinating global efforts to ensure every phase of the event is captured and analyzed. Space-based telescopes like the Hubble Space Telescope, the James Webb Space Telescope, and ground-based observatories across different continents are poised to monitor the star continuously. These observations will help create a comprehensive timeline, from the first signs of collapse to the post-supernova remnants. This level of preparedness reflects not only the scientific value of the event but also the rarity of witnessing a supernova so close to Earth in astronomical terms. Betelgeuse is approximately 642 light-years away, a safe distance for observers, yet close enough for even amateur telescopes to potentially witness the event in the night sky. For a brief period, the explosion could outshine every other object in the sky except for the moon, making it visible during the daytime. Such visibility is expected to captivate people across cultures and generations, reminding us of our shared place under the same sky. Cultural interpretations and historical records show that ancient civilizations once chronicled supernovae, often viewing them as omens or divine messages. Today, however, we can translate their brilliance into data, models, and deeper cosmic understanding. Beyond scientific and cultural implications, Betelgeuse's explosion serves as a metaphor for resilience and transformation. In the death of a star, the seeds of new celestial bodies are sown. The energy released will not vanish, it will propagate, influence, and ultimately become part of other structures in the galaxy. This cosmic recycling is one of the most profound narratives in astrophysics. Nothing is truly lost, only transformed. As we stand on the threshold of this remarkable event, it also challenges us to think long-term, to develop better models for predicting stellar life cycles, to strengthen our observational infrastructure, and to invest in space science education. The more we learn from stars like Betelgeuse, the closer we get to answering humanity's oldest questions. Where do we come from? What are we made of? And what lies beyond the edges of what we can see? In the coming weeks, months, or even years, depending on when Betelgeuse finally explodes, the world will be watching, waiting, and learning. And when that moment arrives, we will not only witness the dramatic end of a stellar giant, but also the beginning of a new chapter in our understanding of the universe.